Hi, welcome back to the lab. Today we'll be talking about the design of prosthetic devices. Now, prosthetic devices are used when somebody's had an injury and needs something to replace the missing part of a leg, in this case. And that missing part of the leg is replaced by this device right here, and the upper part, which we call the socket, is actually used to connect to the remaining part of the leg, as we would in this situation like this. As you can imagine, walking with a prosthetic device may not be as comfortable as we would like it to be. In fact, if you want to get an idea of what that could feel like, you can jump up and land on your heels. That vibration you feel coming throughout your entire body is what somebody would feel every time they take a step with a prosthetic device. Typically, these sockets are made from strong materials such as fiberglass, or in this case carbon fiber. They're very strong and stiff, which allows that force coming from the floor to travel all the way up the socket, and all that vibration gets felt by the body. So for this project, we looked at, can we replace that carbon fiber with something almost as strong, but that can maybe reduce some of that vibration. So in this case, we've used a material called Flax, which is a natural fiber, which is known for its ability to reduce the energy that gets transferred through it. So in this case, maybe it can reduce the vibration energy that goes through that socket. And we've designed some of these in different ways. This socket here is made 100% from flax. This one here has flax on the outside and carbon fiber on the inside. The one on the prosthetic device right here is flax on the outside and on the inside with an internal layer of carbon fiber. And we need to see if any of these configurations makes a difference on whether or not we can reduce the force and the vibrations that get transferred through the whole device. So one of my students designed this really cool test rig here where we can mount one of these prosthetic devices in the vertical position, mounted on a plaster mandrel connected to this load cell down here. And then we can impact it by releasing this plate up here that also has a load cell mounted on top of it. And it made contact with the bottom of this foot. Then we can measure with accelerometers the vibration and the force that gets transferred throughout this prosthetic device in order to understand whether or not different material configurations will in fact reduce the force and the vibrations that is felt by the patient wearing this device.